Okay, so we are looking at Unit 7, Day 4. Whoops. So Day 4, we are developing the expression from a table or a pattern, and we have just looked at our video here. And our speaker said that when we have a pattern, of course we remember that if we have a positive first difference, then we wind up with a linear relationship. And so I can take my linear relationship, noticing the first difference is 3, and write the times table here. So the times table for 3. So I have 3 times 1 is 3, 3 times 2 is 6, etc. And I need to figure out if it had started at 0, then it would be 3 times any number, and I would have 3 times n. But it can't just be 3 times n, because the first value would have been 3 instead of 2. So I'm going to write the values of my times table up above, and I'm going to write 3, 6, 9, 12. Now I want to find what the difference actually here is. So it's going to be 3 minus 2 gives me 1. 6 minus 5 gives me 1. And again, this is always the same difference. And I have 9 minus 8 again gives me 1. So that way I know that I have to change over here. Instead of 3n, I actually have to be 1 less than 3n, right? So this value is always 1 less than 3 times n. So here I'm going to have 3 times n minus 1, and that gives me my term number. Okay, so we have this pattern then, and instead of giving it as a written pattern like on the video, we just have a pattern visualized. So I'm going to start looking here. I have a row of 3, and another 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 row of 3. So I have 1, 2, 3, 4, 5 rows of 3. Here I have 1, 2, 3, 4 rows of 3, and here I have 3 rows of 3, and that means if I double check the first position, this is 6 rows of 3, and we have this extra 1 written here. So how many do I have for each position number? So the number of tiles is going to be 6 times 3, right? We had 6 groups, so it was 19 tiles. And then the next one, I had 16 tiles, and the next one I had 13 tiles, and the last one I have 10 tiles. Now, one of the first things he asks us to do is to determine what it's changing by. And we've already sort of alluded to that as we looked at how it's changing. The fact that this row is missing, the top row of 3 is missing every time we go on. So this is minus 3. So the instruction said that we need to write the times table for our first difference. So we do negative 3 times 1, negative 3 times 2, negative 3 times 3, and negative 3 times 4. I could continue, but I think this is enough because we have 4 showing. So negative 3 times 1, that's negative 3. Negative 3 times 2 is negative 6. Negative 3 times 3 is negative 9. Negative 3 times 4 is negative 12. And again, that means I will write those underneath the actual number of tiles that they correspond to. So if this is my position number, or n, then I'm going to write negative 3 underneath the value of 19. I'm going to write negative 6 underneath the value of negative 6, because that's for the number of tiles for position number 2, and so on. Whoops. Okay, so I know that the number of tiles is definitely related to negative 3n, because again, negative 3 is my first difference and n is position number. But my values aren't actually coming out as negative 3, negative 6, negative 9, and negative 12. The values that I'm getting are 19, 16, 13, and 10. So I've got to figure out how can I transform negative 3 into 19. Well, let's see. How far apart? How far apart are these two values? So the how far apart, that's like subtraction. So I will subtract 19, subtract negative 3. So let's see, if I subtract a negative, it's like adding. So 19 plus 3 is 22. Also, I will subtract 16, subtract negative 6, also happens to be 22 apart. 13, subtract negative 9, also happens to be 22 apart. So it seems like we have a constant value of 22 higher than what we had when we just have the value of negative 3n, because those are my times table values, right? So I had to increase it so that I had positive values. So that means our expression for the nth term of the tiles is number of tiles is negative 3n add 22. Then it says to use the expression for the nth term of the pattern to determine the 25th term. So in other words, I want to know how many tiles, so the number of tiles in the 25th term. So that really means that n equals 25, and I will just replace into my equation number of tiles equals negative 3 times 25 instead of n, and add 22. When I do that, I multiply using BEDMAS to simplify, so I'll have negative 75, add 22, so I will have negative 53 tiles in the last position. That doesn't make a ton of sense, but that's what it's telling me. Maybe I have some negative tiles representing the position. So we have some practice with determining the number patterns then, whether you have the pattern table or just as we have in the examples here, the term number and the term and the expression. So the expression is to help us think, and the term is what we're talking about for number of tiles. Okay, and the term number is the n, so what position we're talking about, or position number. So we can use the exact same idea that we saw in the video. I see here that the first position gives me a term of 1, and then the second position gives me a term of 2, and the difference between these is 1, and it's always a difference of 1. So I'm going to write my 1 times table. 1 times 1, 1 times 2, 1 times 3. It gives me 1, 2, and 3. So then I'm supposed to compare these 1, 2, and 3 to the values that were in my term, 1, 2, and 3. Oh, well, 1 minus 1 is 0. They're not actually any far apart. They're right on. 1 minus 2, also 0, and 3 minus 3 is also 0. So my constant term, or where I'm starting, is actually start at 0. So that tells me then I'm just multiplying n by 1 with no constant. So we can do all of that using this pattern all the way down for number 7. Number 1 gives you a little bit of an idea of what the expression might look like, so it's trying to help you think about this table of values, that the times table that the video demonstration had set up. And when you get down to number 4 and beyond, you'll actually have to set up your own expression, so you might want to use some side paper to set up your times tables.